So everyone here knows a little bit about who we are and what we do, but before we begin, we'd like to know just a little bit about who we're talking to. And for that, do we have any Acadia grads here? And I guess instead of unmuting, you could probably just put it in the chat if that is the case. Okay, no Acadia grads, that's cool. So what industry is everybody from? I mean, do we have software developers? I'm sure we do, but you know, what sort of a developer are you?
There we go. Don't know your chat.
Cool. Nice. Golang backend, that's cool. Clean energy. JavaScript software development, yeah, cool. Fantastic. And pointy hair manager across a lot of stacks. Cool. That's awesome. Okay, and then my last question before we get started is that how many people do we have here that were born before the internet was commercialized? Hello, Mike. Yeah.
Around 1993.
Yeah. Cool. Wow. Awesome. So this is fantastic. This is really awesome. Yeah. Sometimes I wonder why we don't have a PI, which is pre-internet and post-internet, because boy, are we a different world now. No, that's great. This is fantastic because a lot of, or some of the presentation is going to refer to the fact that internet has changed the way we do things, and so has blockchain in a way. We have Ajay who's younger than prehistoric people. That's fantastic, old as gold. Okay, so really getting started. These are some of the snapshots from what took place in the financial crash of 2007, 2008. And the reason why this is important to bring up is because this is what birthed the proposition or the proposal of Bitcoin. And so on October 31st, 2008, an individual, a group of individuals named Satoshi Nakamoto, published the Bitcoin white paper. And this is a quick snapshot of the white paper. They proposed Bitcoin to be a peer-to-peer electronic cash system. And if you can squint your eyes a little bit and just read that first sentence from the abstract, it is a peer-to-peer version of electronic cash that would allow online payments to be sent directly from one party to another without going through a financial institution. And the without going through a financial institution is the key point here, because essentially what happened because during the financial crash, we believe that it caused some sort of disenfranchisement between technologists and just everyday people, the average people. And Bitcoin was sort of born out of feeling disenfranchised by what happened in 2007, 2008. And in January 3rd of 2009, that's when the Genesis block is produced or was produced. And we're going to see very shortly what the Genesis block is. Now, the reason why it's important to bring up Bitcoin in order to understand blockchain is because blockchain is the technology that supports cryptocurrency, and Bitcoin is the very first successful example of having blockchain technology. So our agenda for today's presentation is understanding the similarities between a linked list and blockchain use cases, as well as ending with a little bit of use case focus on gaming and gambling. And that's mostly because Keegan Francis here worked at a company called PBSA, and I'll just leave it to the end of the presentation for him to talk about that. So what is blockchain? It is a decentralized ledger of transactions, to put it really simply. And the reason why decentralized is bolded over here is because of this P2P network. If you look at the image, you can see that every node is connected to every other. And you can see that there's a blockchain running on every single one of these computers. What this means is, going back to that the abstract of what Bitcoin was meant to be, no single entity is responsible for the whole. It's mostly managed by a network of nodes, and that makes it decentralized. So focusing more on what the ledger of transactions is, we're gonna look at what a blockchain is and what's inside it. So this is a Genesis block, and then you have blocks being added to the blockchain. But let's really look inside the block. And this is a really simple version of what is contained within each block. So you can see there's these transactions. And what's important to note here is that the previous hash is 0, simply meaning that this is the first ever block, and this is the Genesis block. Now this hash is a digital signature of the timestamp of this particular, whenever this particular block was produced, as well as all of the transactions inside it. And when the next block is being produced, you will notice that the hash of the previous block is encrusted in the hash of the current block. So on and so forth, as transactions get added to each and every block, you get a new hash for that particular block. And similarly, for every next block, you see a hash pointer to the previous block. And why this is important is because let's say that someone wanted to manipulate a transaction in any one particular block. So for example, if someone wanted to go in and change this transaction from 30 to 3000, automatically the hash for that current block is not going to match this anymore, and it will just change to reflect that change. But when that happens, this doesn't match the previous hash that was encrusted in the next block, and so on and so forth. You can tell that something has been manipulated, something has been changed, and the transactions don't become true anymore. And that's where decentralization comes in. So looking at the diagram from the white paper, the Bitcoin white paper, this is what was shown in the white paper. And I encourage everyone to go ahead and read some of the concepts that are presented in the Bitcoin white paper, because they are really quite an interesting read. So we all know this from data structures class. Ooh, I see 2 chat bubbles here. Oh, thank you, Angela. Sorry, I was distracted by that. So what is a linked list? Put it in the chat if you remember reading about this or learning about this in your data structures class. Yeah, awesome. Okay, let's go one step further. Can anybody try to define what a linked list is? Yeah, linked list. Yes, Andy. Yeah, nodes associated by pointers. Oh yeah, that was smart. It took me a second to get what you were talking about, Patrick. Yeah, this is the definition of a linked list. Smart answer. So to put it, in a sentence format, yeah, not an array. I remember that distinction between linked list and array. But to put it in a sentence, a linked list is a linear collection of data elements in which each element points to the next. And the reason why points to the next is, again, bolded over here, because that's not the case with a blockchain. A blockchain is a backlinked list because, as we saw a couple of slides ago, every single block has a hash that is the previous hash of each block. So blockchain contains data and hash pointer that points to its previous block, hence making it a backlinked list. And it's important to make the distinction between a pointer and a hash pointer here, because a hash pointer doesn't simply contain the address of the previous block, it also contains the hash of the data inside the previous block. And that's why blockchain is a backlinked list. So this is an important slide because of the word immutability. You might have heard that a blockchain is an immutable ledger of transactions as well, and we're going to understand why. So a hash of the previous block is encrusted, again, within the current block, and it enforces immutability because of the decentralization aspect of it, because of the P2P system that blockchains run on. And just to note here, we can run a blockchain on just one node, except it wouldn't really be useful at all because you can just manipulate data inside any one of the blocks, and it would really lose the purpose of having a blockchain as a data structure in the first place. And then the second point here is, in order to rewrite any block in the blockchain, you must also rewrite the previous hash, or change the previous hash. And this is just an example for n-3. You also need to rewrite n-2 and n-1. So looking at this, something that you will notice if you look more into cryptocurrency is you see block confirmations. And what that means is, if your transaction is in any particular block, then the block confirmations number will increase based on how many blocks come after it. And it's just generally said that you should wait for 6 block confirmations in order to be extremely sure that your transaction is successful and it can never be changed. So going to talk about the properties of blockchain. In general, there's 3 properties that blockchain enables just right out of the box. The first one is immutability, and that is the ability for what is published not to be changed. But also, just to note, this is only possible if the blockchain is run on a peer-to-peer network. It must be run on at least more than 3 in order to have an impact of immutability, or have that property really be used. Then the next one is transparency. And as you can see, it's the ability to see how the entire system works, as well as see the activity that takes place inside it. But again, to note, transparency is possible in a blockchain for anyone, only if it's a public blockchain. So Bitcoin, for example, is a public blockchain. If you go to any block explorer, you can look at all of the transactions that take place inside each and every single block. But now, since 2009, we have 3 kinds of blockchains. One of them is public, one of them is private, and then one of them is a consortium blockchain, which is a hybrid of public and private. So based on what permission you have, you can see some transactions, again, depending on what blockchain you're on. And the last one is auditability. And you can only audit any of the transactions inside a blockchain if you can be sure that it is an immutable blockchain, and you can be sure, well, transparency is based on what industry you're in. If there's a blockchain running between accountants and all of the transactions that take place between their clients is on that particular blockchain, we don't really need to see it because that's the accounting firm's business. So auditability, I guess, the factor that auditability would be most reliant on is immutability. And like we saw in this picture, immutability can only be trusted when it is running on more than one node. Excuse me. So the reason why these 3 properties exist in the blockchain is because this blockchain does this better than anything else. Yes, you can use a database to record transactions that take place over a network. That's what we use these days, but you can't trust that the data inside these databases is immutable based on the kind of transactions that they are. So having said that, I'm going to pass this over to Keegan so he can walk us through some of the use cases.
Do you want to switch seats? Would that be most useful, or change the?
Let's just do that.
Okay, cool. Okay, hi. Yes, the use cases. So we're going to examine 3 use cases today. And the first use case is the one that Mrgakshee and I are most passionate about today, and that's the use case of decentralized finance. This is essentially why we started Go Full Crypto, is because we're really passionate about spreading the use case of money in the context of blockchain technology. And decentralized finance is the rough term given to that. DeFi sometimes refers to a more specific area of the industry, which is all takes place on the Ethereum blockchain, which is the #2 cryptocurrency in the world. If you've heard of Bitcoin, most people have. Most people have not heard of Ethereum, but if you're in the tech crowd, it's pretty trendy and a bit of a niche topic. And I definitely encourage you to look it up because they've introduced all sorts of interesting new technical concepts like smart contracts, which is basically the ability to automate the trade transfer and creation of value on the blockchain. You can write smart contracts in a programming language, deploy them onto this blockchain, then allow the blockchain to execute your program with finality. And that is a very appealing thing for a couple of use cases, one being law, another being arbitration and dispute settlement. There's all sorts of really cool things that smart contracts can do, and that ties in very neatly with decentralized finance. The problems at the end of the day that decentralized finance aims to solve is the unbanked problem, which in our eyes is one of the largest problems that is facing the industrialization of the rest of the planet. So 1.6 billion people do not have access to financial services, and if they do, then they might be corrupt financial services. And we're kind of sheltered from this living in Canada. We live in a pretty privileged civilization to be with our financial industry the way that it is. We've got great banks, great financial services, very good financial infrastructure in Canada. And we'd like to acknowledge that, especially in the context of the unbanked, because a lot of people don't live like that. A lot of people, when they go to the bank and try to withdraw $100 or whatever their government equivalent currency would be, that they're just simply not able to do that. And cryptocurrency gives them free access, as long as they have the internet, to access financial services, which is very, very cool. One thing, if you've ever worked in the payments industry or the banking industry, or even if you've been into a bank, then you know that the banking industry is falling behind a little bit on technology in general. We've all heard that they've got their mainframes that are 60 years old, that they're spending billions of dollars to maintain every year. And the banking industry is basically just falling behind. And what cryptocurrency represents is a cheaper, faster, and a more global financial internet. The way that I like to think about this is the financial internet has existed for as long as the banks have been connected to one another, but we've been sheltered from the financial internet to a degree. PayPal and Venmo, they've done a pretty good job of, Google Pay, Apple Pay, they've all done a pretty good job of opening up a financial internet to the general public, but there's still semi-biased access, and we get charged fees for using those services, whereas cryptocurrency is completely unbiased and does not discriminate against who uses its services. And so this, in our opinion, is a revolution in the banking industry. And then, of course, with smart contracts, we get access to a completely new asset class. Cryptocurrency itself is a new asset class simply because it's a quantum leap in what money represents and what money is in general. And so it really deserves to have its own regulation and rules and so on and so forth set aside and by government regulation agencies. And then tokenized assets is a really pretty cool aspect. It's imagine if you could own a host, co-own a host with 1,000 other individuals and earn profit on that host over time. The way that I like to think about this is cash being the worst investment and cash being the thing that most people in the lower class hold. They're exposed to the most financial risk, and they don't have the ability to purchase a house or get a mortgage. But what if you could buy $1 of a house or $10 of a house? That small change in the way that we allow people to procure assets that appreciate in value over time rather than depreciate in value over time, that is one way that we can reduce the inequality gap, the financial inequality gap that is plaguing much of the world right now. So that's my short spiel on decentralized finance, and there's a lot more to be said on this, and you can catch a lot of that in our podcast. So this use case here, gambling, is, I'm speaking from experience here. I worked at an organization called the Peer Plays Blockchain Standards Association, and they are based out of a nuclear bunker in Debert, Nova Scotia, and they focus on the use case of gambling, provably fair gambling and gaming in general. And what provably fair means is that we can generate verifiable random numbers, and we use a blockchain to do that. So one problem in the gaming and gambling space is you kind of have to trust that casino, that online casino, that when they're rolling the dice for you, you know, they're supplying the program, they wrote the code. When that dice roll rolls, it's not somehow skewed in such a way that they always win. Because, well, they've designed the game, they already have that edge. They don't need an extra edge by curbing the luck of the game. And I mean, everyone here is in computer science, so we know that there's no such thing as a actual random number. They come from somewhere, but there's very smart people out there that are trying to create better and better ways to have random numbers enter a system and be used by that system, especially in gaming and gambling, considering it's a multi-trillion-dollar global industry. And so what PeerPlace has done is they've been able to generate verifiably random numbers, and there's a separate third-party institute called the Gambling Laboratory International, I believe it's called GLI, and they've done their independent analysis on PeerPlace and said that, hey, this is actually really cool. You've done something unique. You've actually created a way to create random numbers that is better than what we have now. So that's kind of the use case there. The second point there is a commit reveal scheme makes cheating impossible, and this is really cool. Commit reveals. I encourage you to Google this, and I'm not sure, did we skip that slide for commit reveal, or
We can unskip it.
Okay, yeah, yeah. Basically, I want you to think of like. Actually, you know what? It's a little bit too complicated to explain in words. I would need some diagrams, and this is not quite the forum. Yeah. So within the gambling industry, there's a lot of corruption, and as Mrgakshee alluded to before, blockchains help with establishing trust in a group or a large population of people who may not have trust for one another. So if we take Bitcoin, for example, Bitcoin's used by millions of people all over the planet that don't know one another and that don't speak the same language. And so how do you get those people to collaborate with one another and interact with one another? And that's a pretty tough problem to solve, and blockchain does a really good job of this by taking out as much of the human interaction from the system as possible. And I do blame humans a little bit for being subject to error and greed and corruption. And so I would love to offload as much of the decision-making processes from computer systems that allow them to actually be corrupt. So if we voluntarily adopt systems where those decisions have been automated and put onto a blockchain, then we remove the opportunity for people to be corrupt or to make corrupt decisions. And then we can guarantee fair play through transparency. What that means is if I can see that the random number that was generated and how it was generated, then I can believe it and I can trust it and I can guarantee fair play, which is really cool. It's called provably fair gaming. And there's a link for you right now. They're almost always hiring, and it's a pretty fascinating place to work. You can work remotely. They've got a satellite office in Halifax, and I highly recommend you check them out. And then gaming is the last thing that we'll cover today. And gaming is different than gambling, although they're similar in ways. What I'd like to talk about right now is truly unique items, and this is really applicable within the art industry, for example. But in the video game industry, I'm also going to cover what a truly unique item means there. So if we're playing World of Warcraft, we know that we've got these secondary marketplaces where unique items or rare items can be sold on these marketplaces. But if I'm a developer sitting at Warcraft, or I'm an executive at Warcraft, I might have an incentive to call the database admin and, hey, can you give me that item that's worth $500,000? I want to make a quick buck. And that's possible. And with blockchain, we can make that impossible by guaranteeing something is truly unique. And you don't have to take my word for it. You can go and verify that by yourself. And that's kind of the whole point of blockchain. There's a bit of a tagline that comes with entering the Bitcoin industry. It's called "Don't Trust, Verify." And that's what this is all about. It's okay, you don't have to take my word that this unique item that I'm trying to sell you is truly unique, and you don't have to take my word that it is what I say it is. You can just go and verify what I'm saying on your own, and when you're ready to come and make this purchase from me, then we can go ahead and make this purchase. Non-fungible tokens just means that it can't be divided into many parts. So unlike a Bitcoin, which can be divided into 100 million pieces called Satoshis, a non-fungible token is something that I've got one sword and one sword only, and I can't chop it into two half swords. And that brings me to cross-game items. Imagine if we're playing one game set in the medieval times where I got this sword and I slay a dragon, and then my sword is imbued with an ability with, like, let's say +2 attack. I can then take my cross game item and play a game set in the future and have my sword, the same sword, have that +2 attack that I got imbued from the previous game and use it in another game. And that's because the game in the future items won't be hosted on the game, they'll be hosted on a third-party blockchain service. And so I will be able to maybe buy a sword that has been in existence for 10 or 12 years and has accrued lots of attributes and abilities over time, simply by being used by various characters. And I can take that sword in one game and use that same sword in another. And these games will be connecting to the internet to retrieve these games to be used in it, which will be very interesting. And the last thing is a place called Decentraland, and it's virtual property, essentially. And believe it or not, people are paying millions of dollars for land that does not exist in physical reality. And yes, that I find that hard to believe as well, but yet I do believe that this is the future. It might be far into the future, but I want you to imagine that there's this virtual reality, lots of I like any talk that uses D&D analogies. Sorry, Sandy has sent us a private chat. Back to Decentraland. Yeah, Decentraland, imagine that you're walking through this virtual landscape, and I don't know how many of us have actually tried virtual reality, but it's pretty clunky right now. Imagine that it's not so clunky, and that Walmart or Apple or Facebook has purchased some plot of land, and now they can actually use that land to advertise to their constituents or their user base. You can build whatever you want on this virtual land. And this property is maintained and validated and encrusted in a blockchain so that you can't come onto my land without my property, I can't come onto your land, and you can't build something on my land and vice versa. And so it's all maintained and structured on a blockchain to preserve that community of trust.
I think we have a comment there.
This is that become a Lord of Scotland scheme. I actually don't know what you're talking about, but that's okay. Maybe you can put some more into the chat, and maybe I can weave something in there. But yeah, this actually has real world implications as well. Putting land on the blockchain, there's land disputes all over the world. Buying a star. Oh, I've actually had this idea and I wanted to do it, and Mrgakshee was like, yeah, I don't know if anyone would actually want to buy a star. But
that's not what I said. I said it was a stupid idea.
Well, yes, okay, well, it's true. This actually, like, putting property on the blockchain has real world implications because in Estonia, there's lots of land disputes, especially after the wars in World War II. And if we have more wars in the future, I'm sure there'll be land disputes. And I'll say that I own that piece of land, you'll say you own the same thing, but where is the single source of truth? And so this would be maybe an opportunity for the United Nations or a large trusted party to put things on the blockchain and say, okay, well, before the war, this person actually had it, and just because you came on here during the war doesn't mean you get to take it from us. You can buy 1 square feet of land in Scotland so you can legally change your title to Lord. Oh, that's hilarious. I wouldn't be surprised if blockchain or cryptocurrency enables this. One of the things that cryptocurrency allows us to do is cross-border payments really easily. So maybe this is a barrier if you don't know how to wire transfer that landowner in Scotland, but maybe they'll start selling these 1 square foot of lands in Bitcoin, and we'll buy yourselves a plot of land in Scotland and we'll be Lord Keegan and Mrgakshee.
Yeah, I think what Chris means is whether or not in virtual property as well, you can buy 1 square foot of land in, say, virtual Scotland and still have that title of Lord whatever.
Oh, so like countries creating their own virtual space of sorts.
Yeah, I don't think countries are there yet.
I don't think countries are there yet either. We're still trying to figure out COVID. So yeah, virtual land is not high on their priority list, I imagine. This is actually the end of the use cases. And I'm Keegan, and
I'm Mrgakshee.
yeah, and we're from the Atlantic Blockchain Company.
And then to end this, we actually have a question for you. It's a true or false question. Everything on the blockchain can be trusted. You can type your answers into the chat. Okay, so we have 1 no. Okay, no, yes, false, false.
Sandy sent yes to us privately. Sandy, you've actually been talking to us privately this entire time on the chat.
Sorry.
No problem.
That's funny.
It'll be time vested depending on when the event happened, yes or not.
I like that answer. I would say that's true as well. There's all sorts of reasons why something on the blockchain may or may not be
A
trusted.
prince from Africa told me this is true. Nice.
I think in general, the point is that, well, there's this
No,
block.
hang on.
Yeah.
We have more people typing. So it looks like the general consensus is no, except there's 3 yeses and 5 no's. Okay, cool. So like Keegan was saying, there's a book called Blockchain, The Truth Machine, and that is a really bad title for it because not just because something is on the blockchain doesn't make it true. And with a title like that, it can be misleading to think that, okay, if something's on the blockchain, then it must be true. It has to be true. And that's because you need to find the source of what is being input on the blockchain. And Keegan talked about smart contracts earlier, and that's basically an if, then, and then execute sort of style. And that's where if something happens in the real world, then something can be executed on the blockchain. But you still need to trust the source of information that is being put on blockchain. So the answer to this question is false, to really put a blanket statement on it, but then it can be true based on what blockchain you're talking about. So you can trust that everything on the Bitcoin blockchain is true. And that's because Bitcoin doesn't really change, or Bitcoin is a closed network.
Yeah, it doesn't talk to the outside world at all. Everything that takes place on Bitcoin is Bitcoin related. Whereas on Ethereum, they bring real world data into the system to try and make decisions based on it. That's a really fascinating use case, but it's also a very difficult problem to solve. And it's called the Oracle problem, which is one of the problems that the blockchain industry is grappling with today.
Yeah, and I like what Angela said. You can write pigs can fly on the blockchain if you want.
Which is true. You can write that.
You can write that. But whether or not that's true depends. And then Sandy's saying, I guess I misinterpreted. Can you trust an item added to the blockchain versus can you trust the item itself?
So as long as it's a self-contained system, Sandy, like as long as the items are within the game and they don't bring any real world data into the system, in any way, shape, or form, then yeah, you can more or less trust it.
Cool. That actually gets into one of the questions that I had from this. I mean, when people talk about blockchain, are they talking about the data structure themselves, or are they talking about the whole process around the management of the blockchain? For the consensus algorithm, the Byzantine generals problem, how do you add a block and get it? Because anyone could add something to it, but since it's a distributed data structure, the consensus algorithm has to work to ensure that those nodes are correct.
We didn't talk about consensus algorithms or consensus mechanisms at all in this presentation. It's because it's a whole other box of worms. Mrgakshee did a good job of alluding to it with respect to the whole decentralization factor. But getting those computers to actually agree with one another, that is a whole topic in itself, and it's called consensus mechanisms, and it's the process of how these computers actually decide to agree on what is true. And that's a really tough problem to solve.
And yeah, so to answer your question, what people refer to when they say blockchain, I would say for the most part, it would depend on who you're talking to, but it would just allude to the data structure, the blockchain. And then naming the blockchain would go one step further, because there's the Bitcoin blockchain, there's the Ethereum blockchain. Basically, any cryptocurrency that exists has a blockchain associated with it that is its own.
Okay, that's cool, because I mean, there's lots of problems that you can think of, in terms of auditing and the use cases that you talked about, where you could create a blockchain for it and just have, the hash of the previous hash and all the way back, so you can track the roots of it. But I always get hung up on those problems because I always assume that I need to have a wide enough group in the consensus algorithm to make it worthwhile. But really, you don't need any of that. If you can trust putting something on the blockchain, I guess it's on the blockchain. That's it. Then it's fine.
Yeah.
Like, I don't need a million people to vote.
There's two ways to think about that. And just to clarify, there's closed blockchain and there's open blockchains. So it would be harder to trust an open blockchain because the information that is stored on it comes from the outside world. But for a closed blockchain, and that depends on which blockchain it is, obviously.
Okay, so that's a good distinction. I never knew about open and closed blockchains. That's the distinction I was missing there.
Open and closed to the world, that is. So
Yeah.
Bitcoin is closed to the world. It's a self-contained system. The only thing that the Bitcoin network does is track Bitcoin.
Sure.
And it's an append-only network, but with others.
Yeah, Ethereum is an open blockchain. You can insert data from the real world into it, and therefore you need to be have a little bit more scrutiny when thinking about what is true on the Ethereum blockchain.
Cool. And I think there's also, well, I don't want to hog this. I want to make sure there's see if there's any other questions in the chat here.
Yeah.
I can ask a million questions.
Samuel, to answer your question, yeah, I think that you covered that in the discussion just then. Correct. To just put a nice yes, correct. To digital voting. Yeah, so Estonia, for those who don't know, it was a country that kind of got started in the late 80s and 90s as the Soviet Russia was collapsing. And so they've actually put a lot of resources into developing their digital infrastructure, including e-voting, e-land, e-payments, e-everything. They have e-citizenship. You can apply for e-citizenship as a Canadian even. So has anyone looked into blockchain? Might be adding trust of digital voting. This is crazy. That I think that it's crazy that we're doing voting in the way that we are in today's day and age. It's a system that was set up like 300 years ago, and for some reason we haven't moved voting onto the internet. But blockchain is the perfect platform, in my opinion, for automating and securing voting, because we've got some serious elections coming up here, and yeah, like we've seen in the past, they've been subject to manipulation, and I would love to reduce the margin of error and my margin of doubt with respect to voting.
Yeah.
Yeah.
Are there any advancements in handling big data with blockchain? Yes, there are. And I'm trying to think of an example.
Well, Walmart might be a good example. Like the first thing that should be said on big data and blockchain is that blockchains are actually extremely inefficient data structures. They are really bloated because they've got all this periphery information that does not necessarily make sense to record in the broader context. And what I mean by that is you might have a chain of blocks, a blockchain, and you might publish a block every 3 seconds. But what happens if nothing happens within that 3-second period of time, or that 5-second, 10-second period of time? Then you've got empty blocks, and that's just data that you've published for the sake of publishing. And those blocks still need to be synchronized with other nodes when they get constructed. So Bitcoin, for example, is 600 gigabytes large. There's other blockchains out there that are larger. And so it's a really inefficient way to store big data. But in the context of trusting the big data and using it for some sort of other purpose that, go down the list, whatever use case and you might be thinking of, then yes, I can think of it being useful. Did you have something?
Oh yeah, I was just gonna say, with respect to big data, it might be more efficient. I think last I read, there were use cases on just putting structured data onto a blockchain so that that data can then be used for multiple purposes, as opposed to trying to store everything on a blockchain and then being able to separate unstructured and structured data from that. So it's not a go-to tool to handle big data from the get-go, but it could be to store information that has been structured from the already stored data, so you can trust everything that is on the blockchain then.
I think what we would like to see blockchain used more as is a supplementary system rather than the entire system, which is oftentimes how the blockchain conversation goes. It's like, oh, you can just replace that database with blockchains. Like, no, what blockchain might be actually helpful in doing is using the data that comes out of big data and making decisions with it that are permanent on a blockchain. So we've got one system over here that processes the the big data, and maybe it has an AI attached to it, whatever. And then it pumps out a small piece of data, a much smaller. It condenses that data into something actionable by a blockchain. That seems like a more efficient use case of the two systems, because I think big data, machine learning, they have their place as well. That they're not do-all systems by themselves. You need other systems to help them, and blockchain is no different. Blockchain is just another software that can supplement what you're already doing, rather than be the entire software or the entire replacement for your system.
Cool. So Angela just posted a video on why electronic voting is bad. I'm very interested in watching that. So thank you so much for sharing that,
Yeah,
Angela. And then Samuel says, how can we get started in this world as devs? Are there any common starting paths for something like that? Like Emma? Okay, so I have two answers to that question. You can add to that if you want.
Sure.
It depends on what you want to do in the world of blockchain, because currently there's a lot of demand, I would say, for building smart contracts, and that's contracts that live on the blockchain for something like Ethereum. And there's something called consensus.net.
Or Consensus Academy.
Consensus Academy. Oops. Oh no, auto-corrected that. There. I think that's the right website. Keegan and I both actually got scholarships to do this boot camp 2 years ago, where they take you, it's a 11-week-long boot camp, and they teach you all about Ethereum and smart contracts, and also some of the software add-ons, if I'm understanding your question correctly, Mike, where all of, like, there's digital wallets and there's digital systems or softwares that help you test and work alongside whatever you're coding on the blockchain. So that was a really, really great 11 weeks where I learned a lot. Keegan did as well. It ends with a project. And then the other thing is Hyperledger. We would highly recommend taking a look at the Hyperledger suite of blockchains, because they keep creating lots of products.
Yeah, and Hyperledger is more for the industries that choose to explore blockchain outside of the financial realm. Not always, but in general, the Hyperledger set of blockchains are being used by Walmart, FedEx, Maersk, big shipping companies to do supply chain tracking and logistics. And that's, if you have more of an interest and less of an interest in finance and more of an interest in supply chain, then you want to head towards the Hyperledger route. And if you've got more of an interest in finance, then you want to head towards Bitcoin and Ethereum, and then that's a really deep hole. So you'll find lots of stuff to keep yourself occupied.
Yeah.
Chris Adams, yes, big data off-chain, hash of it on the blockchain. That's a great encapsulation of what I said. Are there any new software add-ons from Mike Cullymore? Can you elaborate on that question?
And while he's typing that, just make everyone aware of the time. We're coming up on the hour. So if you do have any questions,
okay,
be sure to throw it in there.
Yeah, sweet.
Yeah, so that was awesome. That was really good, and that would be I think it would be awesome to do like another follow up on this one as well, and get into, because there's obviously lots of questions and people have a lot of interest in it. So I'll give Mike a second to finish his question here. Oh, there we go. Oh, Hyperledger. Okay.
Cool.
Thanks for coming,
See you, Patrick.
Okay.
Awesome to know, Sam.
Thanks, Angela.
Thanks, Angela.
Okay, well, thanks, everyone. That was great, and yeah, I think it's certainly a topic of interest and something that we can probably follow up on some more. So I appreciate your time, and just keep an eye on the HelloHack Slack. I guess people can follow up there if they have other questions or want to follow up some more. And again, I encourage everyone to go listen to the podcasts. Go Full Crypto.
And always reach out if you have any questions.
Fantastic. Thanks so much, Sandy, and thanks everyone for attending.